For much of the book, we'll be dealing with vector quantities quite a bit, so it's really a good idea that you get really comfortable working with them. One of the symbols that will come up quite frequently is delta, and delta, whenever you see that, it means essentially change in whatever comes after the delta symbol. So this equation right here, delta P, is simply the change in P, the change in momentum. And whenever we're looking at a delta, it's always going to be final value minus initial value. That's always true with the change in some quantity. It's going to be the value at a later time minus the value at an earlier time. So let's say that we're dealing with P initial, P final, and we'd like to know what's the change in momentum in going from this point to this point. So what we're going to do is graphically subtract these two vectors, and that involves placing the two vectors tail to tail. So P initial here, and then P final like that. And we start at the nose of whichever vector we're subtracting, in this case the P initial, and go to the nose of the other vector. So this right here is my delta P, my change in momentum. Another way to look at this is saying, if this is my initial momentum, how would I have to change things to end up with my momentum going in this direction? Well, I'd have to add to P initial a vector along this line to end up with momentum in the direction of P final. And you can see that from this equation pretty easily. If we go ahead and rearrange this by adding P initial to both sides, an equivalent equation would be that P final is equal to P initial plus delta P. This is really kind of an important concept to understand right here, that if we know what some value is initially, it goes through some change. If we add those two together, that gives us our final value. So let's take a look at another example, and let's ask, well, what's the change in momentum between these points here? So what we do is we break this up into little time chunks. So let me look at just this part right here, in which case my P initial would be PB, my P final would be PC, and so I'm going to call this delta P B C. That's the change in momentum between points B and C. So that's going to be P final, which in this case is PC, minus my P initial, which is PB. And if I'm going to graphically subtract these two, again, we put them tail to tail. Here's my PB, here's my PC, and start at the nose of the vector that we're subtracting and go to the nose of the other guy. Right there, that's my delta BC. So again, another way to look at this, if my momentum is initially in the direction of PB, which way do I have to change it to end up momentum PC? Well, my change would simply be like this. Here's another way of thinking of it. If my PB is pointing this direction, which way would I have to go ahead and pull on that vector to get it in the direction of PC? That's really what the change is. It's pulling on that vector to get it moving in a different direction. So then we would look at the next time interval, and this next time interval, which my change in momentum then we'll call delta P CD. Now, this is my momentum at a later time. This is my P final for this time interval. So it's PD minus my momentum at the start of that time interval, which is PC. So if we go ahead and draw these guys, let's see, PC looks like that. PD looks like that. Subtracting these two, start at the nose of the subtracted vector and go to the nose of the other guy. And there's my delta PCD. Again, if my momentum is originally in the direction of PC, how would I have to pull on that vector with my hand to get it going in the direction of PD? So take a look at this section and make sure that you're pretty comfortable with calculating this. It's more important that you calculate it numerically, but understanding how to do this graphically is an important skill because it will help you kind of gain a gut level understanding of what exactly is going on and what some of these things mean.